Well, welcome back, everybody, and welcome to Geothermal Performance, where we're going to actually go through the process of checking a geothermal unit without hooking up our gauges. And yes, that is correct. We never want to hook our gauges up to a geothermal. Think of a geothermal unit as a packaged air conditioner or a packaged rooftop unit that the factory has done all of the refrigerant piping for you, so there is no need for you to hook up your refrigerant gauges to that machine at all. If we did, we would lose ounce by ounce, and then over time, we would have to charge the system up because we removed too much refrigerant from it. So never, ever, ever hook up your gauges to a packaged geothermal. We do have split geothermals, but once we get them charged, the same principle applies. Never hook up your gauges to them, and always do a heat of extraction, heat of rejection test before you determine that there is a refrigeration problem. So let's get into it. I already said this. Don't hook up your gauges. So as we're looking at the testing equipment that we are going to need for this unit, how do we find the GPMs on a geothermal? What we're going to need is a water testing gauge. Now, I happen to have one in my desk right here. So this actual gauge comes in this nice styrofoam package, and it's going to look like that. So it's going to be a PSI gauge that we're going to be using to hook up to particular geothermal units so we can get the PSI pressure off of them. And then once we get the PSI pressure off of them, we are going to get the temperature of the line on it. I know the diagram up there shows you that you are actually pushing a thermometer into the line. And I guess that would be the most ideal thing for you to do if we had such a temperature probe for our geothermal units here at the university. But since we don't have that type of probe for the university, what we're going to be end up doing is hooking on to the copper lines on our systems, and then we'll be able to figure out what's going on with them on our systems. We will be able to figure out what's going on and once we look at the data sheet on there. So these are the three items that you need: the performance data sheet, which should come with the manual, a pressure gauge, and a temperature gauge. Guys, when we're looking at checking capacities of these units, we need to identify where the Pete's ports is, and then we need to find the pressure gauge for PSI. Stick the pressure gauge of PSI into the Pete's ports. I like to use the same pressure gauge for both ports because using different gauges might give you different readings depending on how accurate they actually are. And then get the temperature readings of the line going in, or the water in line of the geothermal. Here's a couple of pictures. The first picture we're going to look at is the water in line, and that's the geothermal water in line. A lot of times we're hooking them up with quick connectors on them, and then we use a radiator hose that goes up to the flow center itself, and then there's your water outline. So what we're looking at here is the performance data sheet for an HTV 036 full load capacity. Another thing that we need to understand about these is there's going to be a couple of data sheets out there for us to look at. One of them is going to be full load capacity. One of them is going to be part load capacity, because most geothermals are efficient and they run a two-stage compressor rather than a single-stage compressor. They're even becoming more efficient than that, is in that they are running inverter technology compressors now on their units. So there's going to be a little bit difference in the performance data sheets that are going to be out there, because we're going to have to force it to go into full load to check it. Now, a couple of things that we need to understand about the actual diagram that we're looking at right in front of us. The water pressure difference, and that's the WPD, is found in PSI because that's what our gauge is found in. So that's going to be found in that document right there. It's going to say WPD. Now you're going to find it in PSIG is what you're going to find. The next thing we need to figure out is what's the entering water temperature. The entering water temperature happens to be at 50 degrees. And we'll just say that theoretically that it's sitting there, okay? Now, I need you guys to understand how to read these charts. Now, you can take the time to do it yourself, or you can listen to me and how I'm explaining it. You see how the 50 degrees, it actually has 1, 2, 3 different categories to check. And why is that? Because we don't know, the manufacturer doesn't know how we are going to install the geothermal unit. So the geothermal unit could be installed in an open loop. The geothermal can be installed as a closed loop. Now, depending on how we install this system is the requirements for such unit. So what they do is they give us data for running the geothermal unit in an open loop system at 1.5 gallons and at 2 gallons. And they give us the data to run on a closed loop system, which requires 3 gallons per minute. And depending on the pressure difference that you're getting on the geothermal unit, will determine the capacity of gallons per minute that the actual geothermal unit is running. Technically, I guess you could say if you're working on a closed loop system that it should be running this, and you're not wrong in doing that. But the pressure difference that we're looking for on this is going to tell us a lot about what's going on with that particular unit. Are we having a problem with the pump? Maybe the pumps aren't pumping and we're getting a 0 psi difference on an open loop system, and that would be determined by that psi difference. So I mean, going through the motions of assuming things is not going to work for a geothermal unit. The next dot that's going to pop up here is going to be the water pressure difference. Now, if we were running a 3-ton unit here with a psi difference of close to 5, well, then we would pick the 5, and then we'd say that this actual unit was running how many gallons per minute? Right there's our gallons per minute. It was going to be running 9 gallons per minute, which goes back to um, it being a closed loop system. So it's running the proper flow through it. So continuing looking at these performance data sheets that we would get off of the geothermal should be left with the customer's house. But if you run into a situation where it's not there, then you need to go back to the equipment, the manufacturer of the equipment, or maybe possibly you might be able to find it online. Either way, the legend shows what the abbreviations are at the top of the chart. Now, this should be somewhere towards the bottom of the chart or top. It depends on the manufacturer and where they want to put it in there, but we can look to that and find out what these different abbreviations are at the top of the chart itself. Now, the ones that we are going to be concerned with is the entering water temperature, which is the entering water temperature. It takes a temperature probe in the water or on the copper pipe and get you a good temperature. But let's go ahead and say that that temperature probe actually was reading 40 degrees. The next step in field checking a geothermal unit is to find how many gallons per minute are flowing through the heat exchanger. So we'll need to understand what WPD is and what PSI is. WPD is water pressure difference. And now that can be found on your diagram right there at the top. And it's going to be found in PSI. So we're looking for a PSI difference in the water pressure of this unit. Okay. So closed loop systems require 3 gallons per minute. Open loop systems require somewhere between 1.5 gallon. That's why they give you that third line there. Let me go back over here. See this 40 degree temperature, and there's 3 different lines in here. Well, this line right here for the 4.5 gallons per minute has to do with a open loop system that's running 1.5 gallons per minute. If we took that by 3 tons, we would find out it would be 4.5 gallons per minute running on that system. On the next one, we're running at 2 gallons a minute. We're running at 6 gallons, 6.88 gallons a minute. And that would correspond to the 2 gallon a minute figure that we're looking at. And then the next one's going to be 9, which corresponds to 3 gallons a minute for the closed loop systems that are running out there. But let's say that the input PSI was 45, okay? and we'll say that the outlet PSI was 40. So there's a 5 PSI difference on that. So we'll take that 5 PSI difference and we'll come over to the data chart and we'll look to see that the 5 PSI difference actually is closest to the 4.5. So that we know that because the pressure difference is close to 4.5, that this actual unit is running at 9 gallons per minute. So from this chart and from the data readings that we got off of the geothermal, we can actually find what this unit's actual heat of rejection and heat of extraction is in BTU capacities for a particular degree coming into it. So we said before that this thing was running close to 40 degrees on this unit. And we're going to be looking at a couple of different ratings up here given to us by the geothermal manufacturer. One is HR. The other one is HE, and they have to do with the heating and cooling of those particular units. So HE is heat of extraction. How much heat are we taking out of the geothermal loop? And the other one that's going to be in there is HR, and that's to do with cooling, which is basically heat of rejection. So rejecting that heat into the ground loop itself on there. And then given a certain temperature and a certain gallons per minute, we can find out how many BTU capacity that this unit actually is running. Now, if you were to actually look at the data sheet, these things are given in decimals, but what they're actually saying is thousands of BTUs. So take that decimal and multiply it by 1,000 to get your number for that particular unit. Okay. So we said that the unit was actually running at a 40-degree temperature, 9 gallons per minute. And what we want to do is draw a line over, and we'll look at cooling first. Draw a line over to the heat of rejection chart, and we will find out that the actual BTU capacity, rated BTU capacity for this unit is 49,500 BTUs. Now we can take that same line, extend that line out, and we can find out what the BTU capacity was for the heating side of the system. And then we see that the BTU capacity for the heating side of the system is 26,200 BTUs capacity. And these are the rated numbers. AHRI took these numbers, manufacturers took these numbers, ran their equipment at these conditions, and they were perfect. And these are the performance data sheets that we see on these units. Okay, now what we're actually going to do is take all these data sheets, data performances off of the geothermal actually. Now let's find out what the actual BTU capacity is for this geothermal. Remember, we just looked at the rated capacities. We want to find out what the actual capacity is for. So we're going to be using this formula to find it. So we need the gallons per minute, which we already found. It's 9.9 gallons a minute. We need the fluid factor. Now, the fluid factor is a little bit different, you guys. We have to understand that every system out there might have a different fluid factor than what the other systems have because they might fill them up with different types of antifreeze, or maybe they're not concerned with the freezing of the actual geothermal loop, but they're just going to use straight water on it. And the fluid factor, depending on if you're running methanol or some other substance in there could be different. But we run straight water here at the university, so we don't have to worry about jumping down to those lower numbers. So 9 gallons a minute times the fluid factor times the temperature difference that you're going to get between the entering water temperature, which was 40 degrees, and the exiting water temperature, the amount of heat it gained or the amount of heat it lost on that particular system. So we got gallons per minute, fluid factor, temperature difference of the ground loop, and multiply all those numbers together. So 9 times 500 times 10 gives you 45,000 BTUs capacity for this particular unit. Now, what does that mean? It means that the geothermal unit that you're working on is actually producing, based off the numbers that we took, 45,000 BTUs of cooling. We'll just call it that. So if the unit is producing 45,000 BTUs and the unit is rated at 49,400 BTUs capacity on it, is this system working okay? Do we have to hook up our gauges to that system? And the answer to that is it within 10%? So within 10% of 49,400 performance data BTUs is 44,600. So no, this system is actually producing within the 10% range for that unit. So there's no need for us to hook the gauges up to this unit. Everything is perfectly fine, and we can move on to our checking the capacitors, checking the contactors, and changing the filter, making sure things are clean in that way, and then walking away from that geothermal unit when it's within capacity range. And we'll come back probably in the fall time or and check out the heating cycle, unless the customer wants you to check both at that point, and the same process goes into it again. So a couple of things. When you're checking these units, go ahead and do visual checks, look for oil, look for clean out the drains, pretty much normal maintenance that you would see on any type of air conditioner or heat pump type of system. Check the functionality of the electric strip heaters, the heating cycle and the cooling cycle, making sure that everything is functioning as it needs to. Take a field test. I'm not a big believer in field tests, but you can go ahead and do that. Do a performance test on it. Make sure it's reading between there. If not, then we need to hook our gauges up to our geothermal unit. I hope this helped uh, determining on a geothermal unit what you're supposed to do. Guys, I was always scared of geothermals. You don't have to be, because you have been trained how to look at these things, how to service them. And if there is a problem on them, then you got to go back to your knowledge of the refrigeration cycle and fix it, or your electrical knowledge and fix it. But they're no different than a heat pump. We just are extracting heat and taking it from different areas of it. So hope you learned a lot, and we will see you in class.